Alright, so today's in class is the daily packet. We're going to do pages 148 through 153. Let me make this a different size. I think this was good right here. So on page 148, or on my page 58 looks like, the first thing you see is this. And what we want to do is look at the connection between f prime, the derivative, and the original function when we look at polynomial and trig functions. So over here you notice that it says f prime. So when f prime of x is equal to 0, what do we know about the function? Well, basically we've looked at the fact that there is a flat spot. The slope is equal to 0 because that's what the derivative is. So we have a horizontal line for the derivative, the tangent line there. But really all we've seen so far is that, we end up with a max or a min. That's what we've looked at so far. When the derivative is greater than 0, that means the function is increasing. When the derivative is less than 0, the function is decreasing because the slope is negative. The slope is going downhill, decreasing. That's what that says, I promise. Alright, so when the derivative changes from positive to negative, so slopes that are positive to slopes that are negative, what happens right in here is the function has a maximum. When the derivative, the slope, changes from negative to positive, that's where the function has a minimum. So we've kind of looked at that, and now we're kind of formalizing a little bit, and we're going to get some practice. So for this one, given the graph of f of x, it's important to point out that this is the graph of f of x, not the derivative. And this over here, we're going to graph possible derivative function. So what I have found easiest is to actually kind of graph a bunch of tangent lines. Actually, that's probably not steep enough. And then estimate the slope of the tangent line at each place, and we make a table. So we can say if x is equal to something, then f prime slope is equal to something else. So with this tangent line that I have here, I would go up 1, 2, 3, maybe 3 or 4. So where was that? Let's see, 1, 2, 3, 4, 5, 6. That's at 7. So at negative 7, I'm estimating the slope to be about 4. You might have a better when using a straight edge than me. And then this one, right in there, looks like it might be 1 or 2. I'm going to put 2 because I'm not sure like where I drew my line. And that's at negative 6. And again, I'm only looking at the slope of the tangent line for my derivative. And that would I say 2. And then the next point we have here is a maximum. And so that's at 1, 2, 3, 4. And we get the slope of the tangent is 0. And then over here, oops, not a very straight line, but I'm thinking that looks to be about 1. And that was at negative 2, and that looked to be about negative 1. This one looks to be about negative 2. Here again we have a flat spot there at 1. So our slope is 0. And then right here, maybe negative 3. So 3, the slope of the tangent line was about, oh no, that's positive. Positive 3. Let's see. Again, we have 0. And that's it. 3, 4, 5. Slope of 0. And then over here we're going to have a negative slope again. And about 3, maybe 4, because I'm not drawing very nice lines. So that was at 1, 2, 3, 4, 5, 6, 7. Positive 7, about, I don't know, negative 4. You might have better estimations than I do. So when we graph the derivative, we're going to graph the x value and then the value of the slope. So at negative 7, I'm going to graph 4, 2, 3, 4. Don't do that to me. 4. At negative 6, I'm going to graph 2, negative 4, I'm going to graph 0, negative 2, I'm going to graph negative 1, negative 1, negative 2. Actually, I think that should be, no, that's right. Oh, we didn't do 0, but we did 1. 1 is at 0. 2, oops, 1 is at 0. Get rid of that one. Alright, so we did 1, and then at 2, nope, I have 3. 3 is positive 3. 5 is back at 0. 7 is at 1, 2, 3, negative 4. So bear with me as I try to kind of connect my dots. Oh, something maybe about like that. So that would be a possible graph. Granted, you might have different numbers than I did and maybe a little more accuracy, and hopefully your graph is a little smoother than that. But again, making this table, I think, for me, is easier. So I can actually have points to plot. Alright, so let's go on to the next page. Now this time we're again given the function value, and that's one of the things we need to make sure we pay attention when we do these, is that what is the graph of? Is the graph of the derivative, or is it the graph of the function? So the approximate value of f prime of negative 4. So we're given the function, but we want the slope of the tangent at negative 4. So 1, 2, 3, 1, 2, 3, 4. Oh. Or 0. At what value of x is the derivative 0? Okay, well that was 1. And then we have another one over here, and that's at 1. And then we have another one over here that's at 1, 2, 3, 4, 5. So I would say that x is 0, and if I were to justify it, I would say slope of tangent equals 0 at, what did I say, negative 4, positive 1, and 5, I think it was. And to justify that, I don't know, slope goes from positive to negative. Flat spots on the graph where the tangent line is horizontal. I'll imagine any of those are getting close to justifying whatever makes sense to you. So down here at number 3 it says, what intervals is f prime of x less than 0? So we want to know when the derivative is less than 0, where the slopes are negative. So I would say that happens right here, from here to here. So that's from negative 4 to positive 1, and then happens again at 5. 5 to infinity. And these are open intervals because at the endpoints it is equal to 0, the derivative. Alright, so when is it greater than 0, the derivative? So that's going to be everywhere it's not increasing and not 0, which happens from negative infinity, oops, to negative 4, and then in between 1 and 5, the two places where it's decreasing. And we can look back up here and see where the function is. Did I get those backwards? No. Yeah, where the derivative is positive, that's where the function is increasing. Okay, so the graph of f prime of x is on the interval negative 3 to 4. So we want to open intervals where the function is increasing. Notice this is the graph of the derivative. So this is not the function, this is the derivative. So f of x is increasing where f prime of x is greater than 0, and is decreasing where f prime is less than 0. So this is going to be the hard part, is remembering We're not looking at slope now, we're actually looking at values. So here is where it's increasing, is everywhere it's above the x-axis. So for this problem, it's only increasing the original function between -3 and 2, because it gets to 0, and then it's decreasing everywhere else because, oh, except for right here, it's not decreasing. So where is it decreasing? It's decreasing everywhere. It's below the x-axis, which is everywhere else except for right here. So we would write that as -2 to 2. And the reason why we have to have two intervals here is because we cannot include 2. Because at, oops, that should be 4. 4. I put the y value. We can't include 2 because at 2, the function's equal to, the derivative is equal to 0. So we have to not include it. So where does there a horizontal asymptote? That is happening at -2 and, oh, did I say asymptote? Horizontal tangent at -2 and also at 2, because slope or derivative equals 0. Alright, what is the slope of the normal line to the graph of f of x at x equals 4? So at x equals 4, the derivative is -2. So the slope for the tangent is -2, which means, let's see, so slope of tangent is equal to -2, which means normal slope equals +1/2. Negative reciprocals. Alright, so I'm going to pause it. Actually, I'm going to stop. And I want you guys to attempt problems 1, 2, and 3. If you get stuck, you can watch the video for number 1 and see if that helps you get started. But I do want you to think about this before I just give you the answers. I want you to think about what it is you can do using the derivative, hopefully, because we are doing calculus, to determine where it's increasing, where it's decreasing, and all of the maximum and minimums. All right? Alrighty.